Warm greetings. Welcome for online video session, Module 4, Software Evaluation. Second topic. Myself Jagadish, Associate Professor, Department of Computer Science and Engineering, Canara Engineering College. In the last video session in the software evaluation, we saw the definition of software evaluation, then the spiral model of the development and evaluation. In that we saw the implementation, validation and operation and specification. In the specification, the software evaluation, whenever it is needed any changes, that basic requirements will be collected and start implementing the requirement of the specification, then checks for validation and release for the operation. It is a iterative process where software engineering has to take places before releasing the product, that is evaluation product to the client. Then next we studied the evaluation and servicing, that is initial development, evaluation, servicing and phase out. And evaluation is a spiral model, and after evaluation of the software application, then it is a servicing. So then and there itself, if there is any changes is required slightly, that servicing has to be done by the one who developed the application. So always it is a organization responsibility to hold the employee who have developed the application of a particular client. Then we saw the evaluation process. In that evaluation process, as when there is a changes in the application, then what are the impact analysis of the requirement or the request by the client will be checked by the evaluation team. Then releasing plan, so based upon the request that is given by the client and impact analysis, then the software evaluation team will check whether it is required, any fault repair is required, or platform adoption or system enhancement, then do changing the implementation, then release the system to the client. So this is what the software evaluation process in the software evaluation topic. Then we check whether it is any emergency repair process or whether it is required any changes implementation in the software evaluation. So these are the topics that what we saw in the software evaluation. So next topic we'll see on the program evaluation dynamics. So program evaluation dynamic is the study of the process of system change. So whenever there is a changes in the software system or a software application, the process of the change is called as a program evaluation dynamic. So after several major studies, Lehman and Belady proposed that there were a number of laws which applied to all the system as they evolved. So Lehman and Belady proposed there was a number of laws before evaluation of the application dynamically. So very important laws they have been given in the software evaluation process. So what are we'll see in the next coming slides. There are sensible observation rather than laws. They are applicable to large system developed by the large organization. So it's not only about the large organization, even the small organization, wherever there is a software evaluation process take places, this process, that is dynamic evaluation process, is the law which are proposed by the Lehman and Belady is implemented in even the small as well as large organization. It is not clear if these are applicable to other types of software system. It's not clear if these are applicable to other types of system. So it depends upon the application. The organization may apply Belady, that is Lehman laws, or depending upon the application also, or whether they have been making use of that law for the evaluation is depending upon the organization. So if they follow that law, they have to follow the various steps has to be followed, where the cost also will be more depending upon the application they have to follow. Okay, so it's a dynamic changes. In the 1970 and the mid of 1980, Lehman and Bellardi carried out the studies of the system changes with a view of understanding more about the characteristics of the software evaluation. During the software evaluation, what are the changes gets happens in the program, and what are the memories, and if it gets changes, then what action has to be taken, etc. That has been studied by these two authors, Lehman and Bellardi, and famously it is been called as a Lehman law of program evaluation dynamics. Even in the examination, they ask what are the various laws of program evaluation dynamics. And these are the likely to be true for all types of the organization of the software systems. And these are the systems in which the requirements are changing to reflect the business needs. These are the systems in which the requirements are changing to reflect the business needs. Okay, and we see the one by one the various law of the Lehman's law. Before that, we'll see this also. The system requirements are likely to change while the system is being developed, because the environment is changing. Therefore, a delivered system won't meet its requirements. So systems are tightly coupled with their environment. When a system is installed in an environment, it changes that environment and therefore changes the requirement. So whenever there is a changes in the evaluation of a program, then there might be adopted in the system or may not be. So if they not be, then what are the changes has to be done for the system has to be taken care. System must be changed if they are to remain useful in an environment. If it is, the system is very important, even though if it is done evaluation, if it is not fit to the system, then it is when there is a most important that we have to change the environment of the system. So the Lehman's law of the program evaluation, there are around 4 plus 4, 8 laws. So we'll see one by one what are the importance of the particular law. The first law states that the system maintenance. So system maintenance is inevitable. Okay, the first law states that the continuing changes or the system maintenance in an inevitable process. As the system environment changes, new requirement emerges and system must be modified. When the modified system is reintroduced to the environment, this promotes more environment changes, so the evaluation process starts again. So these are the first one is a continuous change, where the program that is used in that is a real world environment must necessarily changes or also become more progressive, less useful in that environment. So whenever you do any changes to the program evaluation or a system, then there is a changes in the program or application. So becomes a less useful in that particular environment, because for example, your software application is something like I'm giving you an example. It has been that is of 100 MB, whereas in your system there is no space to install any other software. So when you do the changes in the application, so it may be crosses around 120 MB, where there is no space in your environment, there is in your system. At that time, even though if it has been changed, there is evaluation is done, but it's not fitting to your system environment. So these are the problems being faced by the end users. So one is continuous changing. This may also be happen. You may also come across even in your desktop or laptop, whenever the Windows 7 is been given in the while you purchasing a system, when you give a upgradation for the updation, keep on giving the C drive, whereas C drive it has been you given something less memory. So when you keep on upgrading the or do the changes in the or evaluating the operating system, then at certain point of time when it is that is it may get it evaluate for one time or two time or three time. If the memory is very less in C drive, then there is a problem in the evaluation also, because it won't fit to your system, because the C drive has to be increase the memory. So these are the some of the there is a problem will be come across in when you do any changes in the system. So second law, it states that increasing complexity. So increasing complexity is as an evolving program changes, its structure tends to become more complex. So whenever you add some code to any of the program or there is an existing program, automatically the structure of the program will be more, and extra resources must be devoted to preserving and simplifying the structure. So whenever if you want to add any of the code to the system, due to the evaluation process, at that time some interface is also required for the upgradation and some database is also required. At that time the this extra resources must be added to the simplifying the structure. So this is what the second there is a law of the program, that is state that the system its change structure is degraded. The only way to avoid this is to invest in preventing the maintenance. So sometimes there is no need of upgradation. At that time you should have to use the existing system itself instead of getting upgrading. So you spend the time improving the software structure without adding to its functionality. That's a better option instead of the adding the extra resources or extra code. The third law states that large program evaluation. Large program evolution is a self-regulating process. System attributes such as size, time between releases, and the number of reported errors is approximately invariant for each system release. Large program evaluation, when you do some large program evaluation, in a sense the large system where if you do, then you come across some of the problem or that is size, even the time taken to release the system will be more, and the errors you may be reported more than in the small evaluation program. So this is the third law that states large program evaluation is very difficult. So it suggested that the large system have a dynamic of the whole, and that is established at the early stage in the development process. So the gross trends of the main system maintenance process and limits the number of possible system changes. So there is no need of doing the changes wherever it is necessary. There is for minor also, where it's actually needed evaluation, that is better to concentrate instead of doing the changes to whole system. Okay, for example, if you think that your there is subject itself, so there are 6 subjects in your semester. In this semester also 8 semester subject. So instead of giving a equal time to all the subjects, that is doesn't mean purpose, because some subject may be easy for you and some subject may be difficult. So it is left to the user. So for which system has to be evaluated, there is needed evaluation, or which part or which functionality is required, that is only it is better to concentrate instead of concentrating as a whole system. So that's the third law states. And the there is a structure that yeah, of course this is what the third law states. Always it is better to concentrate only on the which is required application, and which is not, it is better to not to upgrade anything. The fourth law states that organizational stability over a program's lifetime, its rate of development is approximately constant and independent of the resources devoted to the system development. Over a program lifetime, its rate of development is approximately constant. So once we develop a system, it will be approximately, for that program doesn't require any changes. That is saturated. It reaches a saturated state where there is no need of any changes and independent of the resources devoted to the system. So there is a large programming project work in a saturated, that is changes to the resources or staffing may be effect on the long-term evaluation of the system. That is consistent with what the third law says. The same way, even in the fourth law, it states. This law confirms that the large software development teams are often unproductive because communication overheads dominate the work of the team. So fifth law states that conservation of a familiarity. Conservation of the familiarity is over the lifetime of a system, the incremental changes in each release is approximately a constant. That is, you have seen the evaluation process. There is a spiral model. In the spiral model, it is in each releases of the software, one or other it gets keep on changes. So at certain period of time, it will be reaches a common and it's approximately constant changes. So that says the fifth law, and it's concerned with the changes increment in each system release. Adding a new functionality to a system and introducing a new system faults. So something like in your lab program, if you introduce one a new program where it was not done in the regular classes, then if in the examination if you give it, then how you feel? Something the same way, whenever there is changes introduce, there is any changes, then you come across the new faults. So it's very difficult to evaluate. There is clear the errors. The more functionality added in each release, the more faults will be occur. So therefore, the larger increment in functionality in one system release means that will be followed by further releases in which new system faults are repaired easily. Okay, so that is what says the Lehman's law of the fifth law. Okay, the first 5 laws in the Lehman's initially proposed and remaining were added after the further work. Okay, the first 5 laws. What are the first 5 laws? Containing changes, increasing of complexity, large program evaluation, organizational stability, and conservation of the familiarities, where that is where in Lehman's initially proposed, that is author Lehman's initially proposed, and remaining laws were added later. The 6th and 7th laws are similarly and similar, that is essentially says that users of the software will become increasingly unhappy with its unnecessary unless it is maintained and new functionalities added to it. 6th and 7th law, what it states, continuous growth and decline quality. The functionalities offered by the system has to continually increase and to maintain user satisfaction. The quality of the system will decline unless they are modified to reflect the changes in their operation environment. So these are the 6th and 7th law states that in the Lehman's law. The final law reflects that work on the feedback process, although it is not yet clear how this can be applied in a practical software development. Okay, evaluation process incorporate the multi-agent, multi-loop feedback system, and you have to treat them as a feedback system to achieve the significant product improvement. Okay, these are the 8 Lehman's law. The first file Lehman's law was introduced first, and laterly further working while doing they identified another 2, that is continuous growth and decline quality. And the last final law reflects the recent work on the feedback process. It's a feedback process. It's not much important in the Lehman's law. So layman's observations were sensible. They should be taken into account when planning to maintaining the process. It may be that business consideration requires them to be ignored at any one time. For example, for a marketing reason, it may be necessary to make a several major system changes in a single releases. So the likely consequence of this are one or more releases devoted to error repair are likely to be required. So these are the layman's laws of the software evaluation process dynamically, and the definite question will be there in the examination also. So next we'll go about the software maintenance. So before that we'll see applicability of the layman's law. Layman's law seems to be applicable to large systems developed by the organization. That is, it is not clear how they should be modified for that is a small organization or medium-sized system. And this okay, key points: software development and evaluation can be taught as an integrated iterative process that can be represented using a spiral model. For custom systems, the cost of software maintenance usually exceeds the software development cost. The process of the software evaluation is defined by requests for changes and includes change impact analysis. Layman law, such as notation that changes is continuous, describes a number of insights derived from long-term studies of the system evaluation. So next topic will go for the software maintenance. Software maintenance. See, once you develop the product, then the system, then it is software testing. So software testing, if you find any error, then you will do the changes or fix the bugs and return back to the implementation team. So after that, product is been released to the customer. Then if there is any evaluation is required by the customer by adding any of the programs, then evaluation has to take place. As there is you have seen the various stages as well as various spiral diagram of the evaluation. Then the next is software maintenance. So something like purchasing a car is not a your job gets over, not get over. So after purchasing your car, then there is a maintenance of the car, that is regular servicing is required. So that is the software maintenance. Modifying a program after it has been put into use is called software maintenance. The term is mostly used for changing custom software. Generic software products are said to be evolved to create a new version. So in the beginning itself, we saw the custom software as well as generic software. Generic software, the product which is sell in the market openly, and custom software is the product which is designed only for the specific user. That's what the term is mostly used for changing a custom software, because the software maintenance is not for the general purposes. You can see the product which is developed for general user, the maintenance is very less, whereas the product which is designed for a particular customer, then there is a software maintenance. Then you can see the your car as well as general there is public transportation. How? So general transportation, there will be no maintenance. Then if it is your own car, then there will be a lot of maintenance. So that is a better example you can take it. And maintenance does not normally involve a changes to the system architecture. So you are not designing the architecture. Whatever it is already maintained or designed, you are maintaining only that system. Not you are not at all do any changes in the architecture. So always it is the organization will leave the custom, that is for software maintenance, the one who doesn't have a knowledge of the architecture of it, or to change the architecture of the system. So always the organization will leave the people or an employee who doesn't have any knowledge of architecture of that particular system, not the other system, that particular system. So he cannot do any changes as architecture when the customer do the when he requests the person. So that is always a good habit of having that type of ethics. Even it will be profitable for the organization, also it will be benefit for the customer also. So if he says any changes in the architecture when he doesn't know, have any knowledge, the person who maintaining the software, if you do any changes, then the whole system get crashed. At that time you may lose a big losses for the customer as well as for the organization. So this ethics has to be followed. So maintenance does not normally involve major changes to the system architecture. Changes are implemented by modifying the existing components and by adding in new components to the changes. So you can add and do the changes for the software, like something like changing the queries in the DBMS, or changing the interfaces, or changing the front end, etc. That you can be done as a software maintenance. Not else other than that, this work there cannot change the architecture of the system. So types of maintenance. In the types of maintenance, you will see maintenance to repair the software faults, maintenance to adopt the software to a different operating environment, and maintenance to add to or modify the system functionalities. In the fault, there is software fault errors is three different types of software maintenance they can ask in the examination. One is fault repair, changing a system to a correct deficiency in the way it meets its requirements. That is doing something. You can see you are while writing, executing a program, C program or data structures program. If you find any errors in your system, that's what clearing the errors. That is called software faults. Okay, correct coding errors are usually cheap to correct. Designing errors are more expensive, involving rewriting several program components is required. So requirement errors are the most expensive to repair the because of extensive system redesigning. Okay, in the environment adoption, that is maintenance to adopt a software to different operating environment, changing a system so that it operates in different environment, or like different computers. Maybe you are switching on from one system to the other system where you people are not able to that is install that product. You come across in the next that is year, you people have to develop a application, that is a small mini project as a OB, object based education, as well as skill development, as well as you have a one small mini project has to be developed for the DBMS as well as for networking. I hope so. Or DBMS, then definitely we have to develop a mini project where you people develop the project in your laptop, but you people doesn't have a knowledge to install it in the college system. So that because you are changing the entirely, you have to change the that is the environment variables of the system, etc. But people doesn't have that type of knowledge. Let's think about in the college circle itself. If you think about in the there is a larger system in an organization, then it will be very difficult to switch on from one system to another system. And even the operating system like Windows to Ubuntu, or Ubuntu to Fedora, or Fedora to Unix, something. There are a lot of problems there when you are adopting from one environment to another. So this was the there is. Second one is environment adoption, and third one is a functionality addition. So maintenance to add or to modify the system functionality. Whenever there is a needed any functionalities has to be added to the system to fast maintenance, to fast response. Then there is has to be added new requirements of the system by the customer. This type of maintenance is necessary when the system requires changes in the response to organization as a business changes. Okay, so these are the three types of software maintenance that what we see in the software maintenance, and these are three types of, and is important in the examination also. And usually software maintenance distribution, you can see in this diagram, fault repair will be 17% and environmental reduction will be 18%, very less. But functionality, that is adding a functionality to a system and a modification, it will be 65% in an overall when they measure in an by taking on a small area, then they saw that these are the percentage will be happened in the market. And maintenance cost usually greater than development cost. Maintenance cost should be usually greater than the development cost depending upon an application, and affect by both the technical and non-technical factors. Increase as a software is maintained. Maintenance corrupts the software structure, so makes further maintenance more difficult. And aging software can have high support costs. That is because the example, the old languages, if you want to convert this old languages application to the new languages, and then it has to be compiler, then it won't fit, then it takes a lot of time, as well as the cost of that to change old languages to the new, it requires a lot of that is changes is required. So for example, if you can take it as an example of our demonetization, how it was affected for the whole that is people, the whole nation. So kind of it is changing from old note to the new note, how it was difficult. So something, think about this, that is physical that is object. Think about the software, how it is difficult. Even you can see that there is a old films converting, that is a black and white movie, converting into a color that is a movie, and you can see that changes. When old movies, when it is shorted in the year 1960, it was cost around something around 40,000. When it is been converting to a from black and white to the color, now it is cost around 1 crore for just conversion from black and white to the RGB color, that is the red, green, blue. So these are the maintenance is very cost, that is more, instead of developing the software. So these are the maintenance cost. So development and maintenance cost, you can see the system 1 and system 2. You can see here the dark color, what they have indicated is a development cost, and maintenance cost you can see here. And this is in the dollars, because this always they will take it as example of a USA, because the author is from the USA. Whole and together they will take it as a USA example. You can see this for the system 1, the development as well as maintenance cost is all of the same, because see the development cost is same as it is the maintenance cost. For system 2, you can see the development cost is very less than compared to the maintenance cost. Maintenance cost is more. So this is what the example they are given for two systems, system 1 and system 2. The development cost is in the dark blue color, and maintenance in the light blue. You can see the differences. And the dollar they have given it in the, instead of rupees they give it in the dollar, because example from the software, there is a USA company, sorry, USA country. So this is what the development and maintenance cost example. So what are the maintenance cost factors? Maintenance cost factor. What are the reasons for the maintenance cost factor? One is team stability, poor development practice, staff skills, staff skills, and program age structure. So these are the maintenance cost factors. They can ask in the examination, what are the maintenance cost factor reason, or they can ask in this like this also, what are the reasons for the more expensive in maintenance software cost, like this. So be prepared. One is team stability, contractual responsibility, or a poor development practice, staff skills, and program age and structure. So first one is team stability. Maintenance costs are reduced if the same staffs are involved with them for some time. So I used to say in the earlier slides also, in the previous chapter of the module 4. So once you develop a product, then you may switch on to the other company, or you may switch on to the other project in a same company. So when there is any maintenance is required, right, by the end user or by the client, then the organization has to give the responsibility to the person who involved in developing and development of a system. If the person has left the job from the company or organization, then it will be very difficult, because the organization, one who developed the software, that is has to give the project or for the maintenance to the other person. So he has to once again has to verify the code, each and everything, functionalities, interfaces involved, object classes, etc. Whatever they have been used for the development of the application has to be checked line by line, where it takes a lot of time, and he may add around where he may not doesn't have a knowledge of that particular platform, or he may be but doesn't have that much of experiences as a person who one who developed the product. So these are the problems will be faced by the maintenance team or by the organization. It's always better to involve the staff who are already developed the system, and it is better to involve with them for some time. So it is to be something like to retain the staff for the some time until the product agreement get over. So second one is a poor development practice or contractual responsibility. The developer of a system have no contractual responsibility for maintenance, so there is no incentive to design for the future changes. And you can call it as a poor development practice. Also, the contract to maintain system is usually separate from the system development contract. So the maintenance contract may be given to different company rather than the original system developers. So something like how it will be, you people been allotted to something like one organization which is in Bangalore, but due to some problem, or due to some there is no space in the organization, and they may be shifted to the some other place like Hyderabad or Chennai, where you don't get a project at all. So since you are basically you are from there is a Bangalore region, but you may not get a project because you are in Chennai, because since there was no space at all, you have been shifted to the Chennai. So the Chennai peoples, that is in the Chennai organization, since your people all belongs to the Bangalore that is region, so then they may say that you have to wait till the project comes from the that organization that is which is located in the Bangalore. So Bangalore people, the Bangalore organization thinks that the people who are in the Chennai may get the project from the Chennai team. So this will be a problem. Poor development practice, as well as one who developed the product, he may be shifted to some other there is area, and who doesn't have a knowledge of that particular developed platform will be suffering a lot. So these are the problems will be happen in the software maintenance. And staff skills. The maintenance staffs are often inexperienced and have limited domain knowledges. So usually you can see most of the organization, the gatekeepers will be something will be given outsourcing. So outsourcing, since it's been given, there will be something there is will be say what to say, there doesn't have much strength. Since it's for namesake, since one man has to be stand in front of the gate, so for that sake, the outsourcing people will give for the one who doesn't have that much of strength. So usually the gatekeeper is the one who should always have a that is fit and fine to avoid the people who not belongs to the organization. So always something like that. The person who develops the software, he may not be involved in maintenance, because his knowledge is required to some other project. So who doesn't have a knowledge of that particular product, he will be given for the maintenance. Even at that time, the maintenance team will fail to fill the happiness of the customer. So at that time, he may lose the customer for the next project also. From the publicity, from the mouth to mouth publicity also, that particular organization may also lose the other customer from the coming to the particular organization. So these are the problems will be faced even in the staff skills. So program age structure, in the program age structure, as programs age, the structure is degraded and they become harder to understand and change. So as a changes are made to the program, the structure tends to degrade as a program ages. Even of course, like human being or any other product, it also get the even programs also gets ages. So keep on doing the changes. Then there is a where you cannot able to do the any changes. Because it's a old, your compiler is more older than the new technology, and if you reinstall to that system, that then it won't support to the particular environment. So that these are the problems what we faces in the age program. There is age in a sense where it won't fit to the particular current trend. So these are the problems we faced, or these are the reasons that is more expensive of the cost, that is maintenance of the software. So the first three of these problems are fact many organizations still consider the development and maintenance to be a separate activities always, and maintenance is seen in a second class activity. There is no incentive to spend money during the development and to reduce the cost of the system change. The only long-term solution is to this problem is to accept the changes, accept that the system rarely have defined lifetime but continue in use in some forms for indefined period. Okay, so maintenance production is second, that is maintenance production is concerned with the assessing which part of the systems may cause problems and having a high maintenance cost. So maintenance production is concerned with assessing which part of the systems may cause a problems and having a high maintenance cost. So change acceptance depends on the maintainability of the components affected by the change. Implementing a changes degrades the systems and reduces its maintainability. Maintenance cost depends on the number of changes and the cost of the changes depends on the maintainability. So this is production, that is if you require any changes particular components is required, then what will be the cost as to predict beginning itself. So then whether it is better to implement the that is invest money for the maintenance or not, it can be identified in the earlier stage itself. So predicting the number of changes required for a system requires an understanding of the relationship between the system and its environment. Some systems have a very complex relationship with their environment and changes, so that environment is inevitable, resulting changes to the system to evaluate the relationship between a system and its environment. So we'll see the what are the maintenance production is one is that is maintenance that is predicting maintainability, having a you can say predicting maintainability, predicting maintaining cost, predicting the system changes. So in this you can see what parts of the systems are mostly like to be affected by changes request. So if you change the request, something like if you want to change the from there is one branch to the other branches, what are the changes has to be, whether it will be the cost of the fees will be increased, or whether you may fail to understand the subject, or you may understand the subject but you may fail to write it in examination, or you may fail to something like understanding the that is lab, or maybe you may fail to understand your lecturing talk, or you may fail to understand the friends talk, the friends who, because you want to switch on from the that is older friend to the new friend, something like that. So has to be analyzed in the beginning stages, and what parts of the system will be most expensive to maintain. So something like you may change the branch, but whether the branch what you change is more expensive than what the branch you was previously, that has to be seen. And predict maintenance cost, that is what will be the lifetime maintenance cost of this particular system, what will be the cost of the maintenance this system over the next year. So you may spend around 1 lakh this year, and whether that is will be same even for the next year, that has to be analyzed, and how many changes requests can be accepted. So these are the maintenance production for a particular software. Whenever if you purchase a software, so maintenance, what are the there is production has to be done is being analyzed in these steps. So you can see the change production, predicting the number of changes requires an understanding of relationship between the system and its environment. Tightly coupled system requires changes whenever the environment is changed. Factors influencing these relations are number and complexity of the system interfaces, the number of inherently volatile system requirements. Third one is the business process in which the system is used. So factors influencing these relationships are number and complexity. Number and complexity of the system interface, number of inherent volatile system requirements, the business process where the system is used. So the number and complexity of the system interface is the large the number of the interfaces is used in the system, and the more complex these interfaces, the more likely it is that interfaces changes will be required as a new requirements are proposed. The number of interfaces is more and complex, then more likely that interfaces changes will require new requirements are proposed. So that is one thing. And number of inherently volatile system requirements that reflects the organization policies and procedures are likely to be more volatile than requirements that are based on the domain characteristics. Business process in which systems is used. As a business process evolve, generate the system change requests. As business process evolve, that is you are doing some business with the help of that particular software. Then as your business gets evolved, even the particular software has to also get upgraded. So generate the system changes is requested. The more business processes that use a system, the more demand for the system changes. So you require some lot of changes is required for the particular software, then even the cost will be more is reflected in the application. Complexity metrics, or there is a production of the maintainability can be made by assessing the complexity of the system components. Studies have shown that most maintenance effort is spent on a relatively small number of system components. Complexity depends on the complexity of the structure, complexity of the data structures, object methods, and modularized sizes. Okay, these are the list, and we'll see the metrics that can be used for assessing the maintainabilities are. So there is metrics that can be used for assessing the maintainabilities are as follows. One is number of requests for correctivity maintenance, and second one is average time required for the impact analysis, and average time taken to implement a change request, number of outstanding changes requests. So one is number of requests for corrective maintenance, and increasing in number of bugs, failures may be reported, may indicate that more errors are being introduced into the program than are being repaired during the maintenance process. This may be indicate the decline in maintainability. So you can see that these are the metrics to measure the maintenance production. Okay, in that first one is the number of requests for corrective maintenance, and increasing in the number of bugs and failure reports maybe indicates that the more errors are being introduced in the program than are being repaired during the maintenance process, and this may indicate the decline in maintainability. So if you introduce a more program, you may get a more errors. At that time the maintenance will be more difficult and it decline in maintainability. So this is one of the metrics that have been used to measure the maintenance cost or maintenance production. Average time required for impact analysis. This reflects the number of programs or the components that are affected by the change request, that is change request. If this time increases, it implies that more and more components are affected and maintainability is decreasing. More and more components, if you are increased in the maintenance, then automatically the maintainability will be decreases. Average time taken to implement a change request is same as the time for impact analysis, although it may be a correlate, correlated with it. This is something the amount of time that you needed to modify the system and its documentation after you have accessed which components are affected. So, an increasing in the time needed to implement a change may include a decline in maintainability. So, if you take a lot of time for doing changes in the or maintenance of the system, then that is by adding, keep on adding the program that is as per as customer requiring evaluation taking, then the maintainability will be more decline in these cases also. Number of outstanding changes requests and increasing in the number of over time may imply decline in maintainability. If you take more number of time, then automatically the maintenance will be decline. So these are the four steps has been taken, or four metrics used to assess the maintainability. How we assess your internals or how we assess your that is assignment. These are the four way they assess the particular software maintenance. If any or all of this increasing, they may indicate a decline in maintainability. Any of this, if it is increasing, that is something number of requests for corrective maintenance, average time required for impact analysis, average time taken to implement a change request, and number of outstanding changes requests. So these are the four metrics or process metrics used to assess the maintainability. So system re-engineering, we'll see it in the next online session. That is a part of the software maintenance. By this, I wind up this second video session of the software evaluation. If you have any doubt, you can ask in the online session.